It doesn't matter if you're trying to print it, render it, or animate it. If you're trying to represent something in 3 dimensions, you need a 3D modeling tool. And they are not all the same. Some are built for precision, some are built for speed, and some are just for reference. And depending on what you're trying to do, design a building, print a furniture piece, or document an existing space, the method you choose completely changes the result you get. In today's video, I want to talk about 3D modeling, something that can feel a bit intimidating when you're just starting out. I will break down 3 main ways of creating 3D models, what each one actually produces, and what you can do with it. First, manual 3D modeling using apps or software like SketchUp, ShapeR3D, Rhino, or Revit. Second, AI-based 3D generation, where you can create 3D models from images with online platforms such as Item3D. Third, reality capture, where you use scanning apps on your phone or tablet to capture real spaces. One thing before we start, this is not a deep dive, this will be a broad overview of the different methods for 3D modeling. So if you would like me to dive deeper into any of these topics, just let me know in the comments. So let's start. Manual 3D modeling. This is the most traditional approach and probably what most people think of when they hear 3D modeling. You are building everything from scratch. You take measurements, draw geometry step by step, and shape the model yourself. Now, within this category, there are a few different approaches. First, classic direct modeling. Apps like SketchUp or ShapeR3D work this way. You draw lines, create surfaces, push and pull them into shapes. It's intuitive, accurate, and fast to learn. The model you get is a clean geometry, and that matters a lot because clean geometry means you can take that model into a rendering software like Lumion or Enscape, apply materials, add lighting, and produce a photorealistic visualization. You can also export it to other tools, modify it easily, and keep working on it at any stage. There is also a more advanced form of direct modeling using software like Rhino. Instead of just pushing and pulling basic shapes, Rhino works with highly precise curves and surfaces. This is especially useful for complex geometry, things like curved facades, organic forms, or custom design objects that would be very difficult to model in simpler tools. On the other hand, software like Revit or ArchiCAD work differently. Instead of drawing shapes, you are placing real building elements, walls, floors, doors, windows, that carry information. Materials, thickness, structure are all connected. If you change something in 3D, it updates everywhere in your plans and sections. The output here is not just a visual model, it's a data-rich model built for real projects and construction documentation. This is different from SketchUp and the other basic 3D modeling tools because there the model isn't smart. A wall is just a box, a window is just a hole. There is no embedded information beyond the shape itself. Then there is parametric modeling, tools like Rhino with Grasshopper. It's more advanced. You are not only modeling, you are creating a system that generates geometry based on rules. The learning curve is steeper, but the output can be great. However, in my case, we mostly work on relatively small-scale residential projects with unique geometries, so I don't rely much on software like Revit or ArchiCAD. We simply don't need them. We mainly use SketchUp and AutoCAD, and for now this works really well for us. Now let's move on to the second category. AI-based 3D generation. This is a newer approach and it's evolving very fast. Instead of building everything yourself, you start from an image and let AI generate the 3D model for you. Here I want to talk about the platform I've been using called Item3D. You upload an image, one or several from different angles, and it generates a 3D model with structure, textures, and colors. You can regenerate if you're not happy with the result, edit parts of the model, and after that you can export it in various formats, for example for 3D printing. It's fast. For something like a piece of furniture, you can go from an image to a 3D model in minutes. You get a textured mesh, it looks great visually, and it's very useful for things like 3D printing or dropping an object into a scene for visualization purposes. It's practical and fast. Of course, there are still some limitations. It's not the same as a manually built model. The geometry isn't always perfect on the first try, but these tools are improving rapidly and getting better and better every day. So AI generation is all about speed. You trade some control and precision for a much faster workflow, and it can be very useful for quick visualization, object capture, and 3D printing. And finally, the third category, reality capture, also known as photogrammetry or LiDAR-based scanning, depending on the method used. Instead of building a model or generating one from an image, you are capturing something that already exists around you. You can use your phone or tablet to scan a physical space or objects. Apps like Polycam read depth and geometry in real time and turn it into a 3D model automatically. Walk through a room, scan it, and within minutes you have a digital version of that space, walls, furniture, ceiling height, all of it. And today, these tools go a bit further than just capturing a rough model. Some apps can generate measured floor plans, detect walls, openings, and even give you usable dimensions directly from the scan. For architects and designers, this is incredibly useful. If you're working on a renovation, instead of measuring everything manually, you can scan the space and get a base model or floor plan almost instantly. Most of the time, you get a dense, textured mesh, sometimes combined with a simplified floor plan or basic geometry. It can be quite accurate, especially with LiDAR, but it's not the same as a manually built model. The geometry isn't as clean or structured, and depending on your project, you may still need to rebuild or refine parts of it in a modeling software. You can render it, and in some cases, even use it directly, but for more detailed work, it's often used as a starting point or a base to build on. So 3 different ways, 3 different outputs. Manual modeling when you need precision, clean geometry, and something render ready. AI generation when you need speed and you are working with objects for visualization or printing. Reality capture when you're dealing with existing spaces and you need a fast, accurate reference. Also, sometimes you can get great results from combining these techniques. A building that needs renovation, for example, might be scanned through photogrammetry, then refined it using a manual 3D modeling tool, and finally use AI generation to add furniture, generate context, or explore different design options around that space. That's why it's important to understand the strengths and limitations so you can choose the right approach for your project. If you want me to go deeper on any of these, a full tutorial, a real project walkthrough, or a tool comparison, let me know. And also, if there is another 3D modeling technique you are using, also let me know in the comments. And that's it for this video. Thank you for watching, and if you still have some time, you can check this other video here, and I will see you in the next one. Bye!